So we're going to check for mediators in multiple regression. Okay, side note, this guided homework has been broken down into 2 videos. So the second video, I made that first. So that answers questions 7 through 14. Just scroll down to the bottom of the worksheet there, and there'll be the videos embedded here, and there's a YouTube URL if you need to go there. So here's the first part. We're going to go ahead and run a regular multiple regression using complaints and helpfulness as IVs and satisfaction as the DV. So that's what you do first whenever you're looking for a some kind of mediator. It should be coming from a regression model somewhere. So that's what we're going to do first. So the criterion variable is customer satisfaction. The predictor variable is complaints, and what we're thinking is a mediator is employee helpfulness. But again, we're going to run this as a regular a regular multiple regression, and we're going to check the assumptions. So from our multiple regression checkoff list, the only assumption we're going to run beforehand is whether there's a linear relationship between each of the IVs and the DV. Okay, so let's check those real quick. Now, there's several ways to do it. We can go ahead and make a scatter plot between the two, but we can also just check the correlations between the two. So if the correlations are not 0 or close to 0, we can consider that a significant relationship. So let's just go ahead and do a correlation between all 3 of these. Oh, look at that. I did that. I am so good. Click OK. And our correlations between all the DVs, nothing 0. And they're all significant as well, right? Notice the significance levels are zeros all the way across. So all the correlations are significant, which proves that they have a linear relationship. So the other 4 assumptions we're going to go ahead and check after we run the regression. So I think it's time to run the regression. Yeah, so let's run the regression. Let's go back to our data sheet. So our DV is customer satisfaction. We're just going to kick in complaints and helpfulness. So remember, this first part is just a multiple regression model. We're not checking for the mediator or anything. So we want R-squared, descriptives, part and partials, derby, clicky, plots, z-prid on the X, z-resid on the Y. This is our heteroscedasticity check. Continue, save, Multicollinearity. It's going to be our multivariate outlier check. Click continue. That should be okay. Click OK. So let's go back and take a look at those assumptions. Multivariate normality. Okay, that's going to be our Multicollinearity. So let's scroll down to the Multicollinearity. So our maximum Multicollinearity for our data set was 12.87. A pulled up Multicollinearity sheet. We're going to use the critical alpha 0.05. I believe our sample size was, 250? And we only got 2 variables here. So according to this, we would have to have a critical, if we had any piece of data that was greater than 16.98, that would be considered a multivariate outlier, and we do not, again, because our maximum is only 12.874. So we did not violate the assumption number 1. Assumption number 2, autocorrelation, also called independence of sampling, independence of observation. Autocorrelation is what it's really referred to in a multiple regression model. So to check that, we would look at our Durbin-Watson. It's up here somewhere. Found it. It's way up here on the model summary box. Let me just drag this over so you can see it. So our Durbin-Watson, is it between 1.5 and 2.5? Yes, it is. So we did not violate the assumption of autocorrelation. All right, next assumption, homoscedasticity. That is the one with the scatter plot. Let me move this back in. Yeah, okay, scatter plot. There's our scatter plot. Double click. It's going to add, we're going to have to add the best fit line here. And we're going to add the lowest line. Okay. We want that to be as flat as possible. Click apply. Just double click anywhere. There it is. So it's relatively flat. So we did not violate the assumption of homoscedasticity of variance. In other words, the residuals are pretty much the same as you go from left to right on the x-axis. That's basically what you're checking for. So we didn't violate that one either. Yay! Last assumption checked is multicollinearity. Remember, multicollinearity is if two of your IVs are very strongly correlated. If they're strongly correlated, more than 0.8, that could be confusing to the model. Okay, so that's what multicollinearity is. We're going to go ahead and check our VIF and or our tolerance. So it's on the coefficients box here. Let me squeeze it over so you can see it. So our tolerance is greater than 0.1, so that means we did not violate. And or the VIF is less than 10, we did not violate. So we did not violate the last assumption of multicollinearity. So we're almost done. So does this regression model hold water? In other words, is this a significant regression model? So we're going to go back to our output. We're going to look at our ANOVA. Let me move this over. ANOVA, there it is right there. Yes, this is a significant regression model. So what was the effect size? Well, let's go look at the R squared, right? And there it is right there, 0.124. That is your effect size. In other words, you can explain about 12.5% of the variance in customer satisfaction based on employee helpfulness numbers and the number of complaints at the store. So remember, an R squared of 0.14 is considered very strong for this model. So this is somewhere between medium and strong, leaning towards strong. Okay, and that wraps it up for the first 6 questions. Again, questions 7 through 14 are answered in the second video. But that's it. MGZ out.